So question 13, graph the following function using the techniques of shifting, compressing, stretching, and or reflecting. Start the graph of a basic function shown to the right, and then find the domain and range of the function. So again, we're talking about the square root function. That's our parent function. Notice the plus 5 should make it move up 5, and then since the negative is on the inside, that's a left and right concept, so that means it should reflect it across the y-axis. So that's a reflection over the y-axis, since it's on the inside. And then there's a vertical shift up 5. So moving up 5, and then instead of pointing to the right, it should point to the left. Looks like this first graph is doing that. This one's still pointing in the same direction. This would be a reflection over the x-axis, and that would have to be on the outside. And that's a movement of down 5, and we should have went up 5. So this one's all backwards. So we can kind of double check it by putting this graph into the calculator and see if it matches the one we think it is. So y equals in the square root of negative x, and then the 5 on the outside. Graph that, and that does match the same graph there, so that looks good. Now, as far as domain goes, since we do have a radical involved, there's a domain restriction, but notice how, because of the reflection, the graph is now doesn't have a left bound, so it goes negative infinity, but the right bound is going to be 0. It stops at 0. As far as the range goes, notice that the graph is above 5, so it does have a lower bound, which is the 5, and then it keeps going up to infinity. So again, it's easier to identify the domain and range by looking at the actual graph, interpreting it. So again, if I look at the table, we shouldn't see any, notice how when you get to past 0, notice that 1s, 2s, and 3s, those all give you errors. That's domain restrictions. But once you get to 0, we do get a 5. And then if you keep going negative, we do get y values. And notice how they are gradually increasing. But notice that the smallest y value was at 0, 5. That's the smallest y value. And then they just keep getting bigger, just not by much, but they do keep growing. So it does seem to be going towards infinity on the y values as well. So again, notice how, again, we can use technology to kind of verify our thinking.